Okay, 1-5, comparing, ordering rational numbers. Here's our homework thing, 9 and 10. Open up the book here. Again, by this point here, you should be very skilled at the greater than, less than, equal symbol. I don't really want to go through and read this all word for word, but they talk about here some different rainfall amounts going on here. Here they all are. One thing that I am noticing here, and I would hope you are noticing too, is I'm seeing some numbers in different forms. I'm seeing some that are fractions, some are decimals, some are positive, some are negative. So, again, I got plenty of number lines right up here. And when we are comparing and ordering stuff, number lines can be extremely useful for this project. I got a big pile. You are more than welcome to take 1, 2, 3, 5. I can always make more copies. But when we are, and I can make more copies available too, so help yourself, please. I'll take one right now. And I'll use one too. But the
I'll take one.
sure, so I will use a number line myself. Okay? And I will practice on a number line here doing a little comparing, but for the moment, the book already has one for us, and we'll just go with what the book has. But what they have done, I get so nervous with my touch a cord. Any days? I'm leaning against my HDMI cord here, so you know how this works with my technologies. I get jittery. But anyway, what they have done is they have plotted these 5 values on a number line. And they've kind of modified the number line slightly to meet their needs. The number line is set up, it goes up and down. What's the scale or the increment between the lines? When they built this number line, how did they set it up? By halves, right? Because we can see, go to 0, there's a half, there's 1, there's 1 and 1/2, 2, negative 1/2, negative 1, negative 1 and 1/2. So that's how they built it. But in certain spots here, they have added some extra lines, such as between negative 2 and 3, they've cut it up a little more to represent what? Half, right? There's negative 1 and 1/2. Half, half. But here, what did they do?
4.
Right, they cut it into fourths. And they did that just to help illustrate where negative 2 and 1/4 is. And then over here, and I guess over here too. You can't see the first one I pointed to, but. So here they've cut it into eighths. So again, you're making it this precise, not really that critical, to be honest with you, as long as we're in the general ballpark here. But they plotted all 5 of these points out here. And once that's done, it's real easy just to look at the number line, and we should be able to clearly see which is the smallest value, which is what? Refocus. Refocus. Nothing's calm around here. Okay, so what's the smallest value? Negative 6 3/8. What's the largest value?
1.8.
As a real number. 0.8 is not a real number. 1 and 1 4/5 is fine, or 1 and 8/10. Thank you. Real numbers, guys. Okay, but and then these values fall somewhere in between. So a number line can be very useful, where if we plot the values on the number line, we can merely use it as a visual reference to, they may want things in order from least to greatest, greatest to least, Who knows? So it's not required usage, but it is a tool that is available to you if it helps you. It can be very helpful, very, very helpful. So please use it if you find value in it. 1 through 8 here, and please, just do this right in your workbook. You do not need to recreate this number line here.
We can't write it on workbook.
You can write in your workbook. No, I didn't say you can't.
Our workbook anyway at the end of the year, so.
Yeah, you can write in your workbook. Well, don't deface your hardcover, but you can write in it. It's just I check your homework.
In your
Well, we've been through this before. It's the same deal. But this one, again, I don't want you to waste time recreating this whole number line in your notebook. It's wasting your time, okay? Just do it right in the book. Hey, if you want to do it, hey, all the power to you. I won't stop you, but I'm just thinking it's a lot easier. So, with this one here, I don't really want to write on it much, but what have they cut the number lines into? What is the fractional representation here of each of these bars? Like if I point here, or right here, this first one, what value is represented at that bar right there?
No, 1.
Right. We'd have 1/10, 0.1, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10, or 1. 10/10 is a whole fraction. Whole fractions equal 1. So it's cut into tenths. All right. What about if it was decimals? What is the value of this? 0.1. 1/10. 0.1. 0.5 is 5/10 or 1/2. So 0.1, 0.2, 0.3, 0.4, 0.5, so on and so forth. What about this one right here? Right here. Zoom in. What is the value of where my pencil is right now? Negative 1 1/10 or negative 1.1. So if it helps you, you can fill in fractions, decimals, whatever you want to use here. And again, I don't, they get real specific here. I mean, as long as we're in the general ballpark, either on the line or between the lines, that's good enough. What about looking at number 7 there? 1 7/8. So we already talked about our number line is cut into tenths. 1/10, 2/10, 3/10, 4/10, 5/10, so on and so forth. Where would 7/8 go? Or how could we figure out where to plot that? What would be our strategy we would want to use? Yes, it's exactly what I would do. So what is 7/8 as a decimal? You'll get a ton of value in the rest of your math career if you can memorize some of these equivalents. I mean, the thirds, the fourths, the fifths, the sixths, not the sevenths, but the eighths, the ninths. Basically, everything except for the sevenths is pretty easy to, there's patterns.
1.875.
1.875. So between what two values would I put my point then if I want to plot 1.875 on my graph?
Between 1.8 and 1.9.
Exactly. So as long as you get a dot for this one somewhere between the 1.8, which is over here, and the 1.9, I don't care where it is, you just put it in there somewhere. And that's, you can't even see, but it would be right here. Right there. There's 1.9 right there. There's 1.8. So my point is somewhere in between 1.8 and 1.9. Agreed? That's where 1 7/8. So that's where it would be. All right. So I don't think we need to talk about this too much more. Agreed? Fair enough. Okay. I can certainly help anybody that wants to practice it later. All right. Number line work. 9 through 20, talking about ordering. Again, it says use a number line, and you can use a number line, but I'm not requiring you to use a number line. There's a number of different ways you could approach these here. Now, it's probably most useful, whatever you decide first, though, it's going to make all the sense in the world to represent the two values so they look the same. So what I mean is either get them both as decimals or get them both as fractions. All right? Some of them there, it's just hard. I mean, you may not know 3/8 off the top. Anybody know what 3/8 is as a decimal?
Nope.
Well, do you know, well, if you don't know that, do you know if it's greater or less than 4/10? Guys, Kylie, pick it up.
I got it.
Okay, I don't know what we're doing here, why we're throwing stuff around the room. I don't like throwing stuff though that much, especially when we're doing math class. I like it even less. So what are you gonna do? There's two different ways. I could figure out 3/8 as a decimal. So I'll just write this down here. And we're gonna just look at it both ways. But I'll tell you right now, 3/8 as a decimal is 0.375, okay? So we know the symbol, right? 4/10, 0.4 is greater than 0.375, agreed?
Yep.
So, but I could go the other way with this too. All right? So what's this as a fraction?
4
This is 4/10, right? Simplified.
2/5.
So I have 2/5 on this side, 3/8 on this side. So how do I compare those? Two different strategies you could consider. One, no, what do you guys think? What's one? There's two perfectly good strategies here. What's one?
Find
The greatest.
Right equivalent fractions? That works. So what's my common denominator? 40. What goes up here?
16.
Yep. What goes over here?
15.
So once again, 16/40 is greater than 15/40, right? So same answer there. So you can compare fractions that have, you can't make that comparison though until they have the same denominator, because we couldn't do that up here. If you're looking at 2/5 and 3/8 and go, well, 3 is bigger than 2, 3/8 is greater, well, that's not right at all, is it? No. Plus, we started with 4/10 anyway. So you can only make the comparison between fractions if they have a common denominator. So you would rewrite the fractions. In a decimal case, you may have to generate a fraction yourself and then find the common denominator. Anybody know the other method we could use to solve this? I got 2/5 here, 3/8 here. The fastest and easiest of all three methods.
the cross thingy.
Cross products. Right. How's cross products work?
So you times the 2 times.
Right. Remember, it's like we make the x.
So 2 times 8.
2 times 8 is 16. 5 times 3 is 15. 16 is greater than 15. Greater than. So regardless of how I did it, and we did it 3 different ways, all are fully acceptable, but the bottom line is every time we ended up with the exact same answer. Okay? So you can convert fractions to decimals, compare two decimals. Easy peasy. You know how to compare decimals. You can write equivalent fractions that have the same common denominator. That's something we've practiced in the past couple lessons. Or you can use cross products. Multiply just like the x there. Numerator times this denominator times this numerator. And then compare those products to each other. All right? Good with that? So, remember, and this is very important here. Now, negative values go the other direction. So if I write, just for example, 0.5 and 0.4, what's the missing symbol?
What?
Greater than, less than, or equal. Agreed? 5/10 is greater than 4/10. It sure is. But what's the missing symbol?
Less than.
Right. And let's think about it with whole numbers, just to illustrate. And I'm going to use the number line here to help this out here. If I plotted all these points here, so here's my 4, and here's my 5, what's greater? Well, 5, right? But with the negative values, and again, the greater value always lies to the right. The greater value is -4. So it's really important that you're considering, is it positive, is it negative, and how is that going to impact my answer, right? Because it's easy to just go 5 is greater than 4, which is true, but -5 is actually less than -4, and I can prove it. It's right here on the number line. -5 lies farther to the left than -4. Agreed? So it's incredibly important. They mix you all around here. They move it all around. They got positives, negatives. You need to be very careful that you are, yeah, you guys can,
No, but for 34 and 36, do you want us to do calculators?
um,
What do you want us to do?
I don't care. You don't have to do those. You won't see anything remotely like that on a quiz or test. You can skip 34 and 36. Great question. Thanks for pointing that out too. Yep, skip 34 and 36. You won't see anything like that level, so. Right. Okay. I'll give you guys a couple here. So, and then we'll look at ordering and then we're done. So we should be able to get this done in time. Number 15. And number,
Can you move up?
sorry.
Oh no.
I guess they're all, yeah. 17, I guess.
Wait, we're doing 15 or 17?
Both.
Okay, we can volunteer, right?
Nah.
Yes. Yes.
Are you
I will
doing it?
start crying if you pull popsicles in. I will.
In fairness, the pool's getting smaller and smaller around here, so.
So we can volunteer. Okay.
Well, I'll put it to you this way. If I wasn't happy with how things were going, do you think I'd let you know?
Yes.
I think so too.
I think I know 15.
Do I seem happy with how things are going right now?
No.
Oh,
Yes.
I don't.
Yes.
Dear.
I think I know 15.
What? Oh, I am happy.
You are?
Do I seem happy?
No.
Oh,
Yeah, you seem happy.
I thought I'd feel happy.
Well, you don't express your
Mr.
feelings.
Melcher, is 15 greater than?
We'll discuss. Why would it be greater than?
Because, it just is smaller numbers, you know? Smaller negative numbers. That's my
It's not
conclusion.
really a good proof. Just looking for
Well,
a little more
unless you knew-
comprehensive explanation of why that would be true.
You know?
Because negative, it's because it's greater. Negative is.
Well, you would need to, I don't,
No, it's greater.
okay. I don't know if I would convert both of them to decimals. I mean, that's, you know, if you just love making decimals, then what you could do, I can tell you this right now, this would be 0.6. And you could set this one up to
I don't know how to do it.
13 goes into 7,
Oh, wait, never mind.
5. And it doesn't even matter what comes next, does it? Doesn't matter, I mean, I'm not done, but who cares? Because does it matter what's in the hundreds, thousands, so on and so forth column? Not really, because the proof is right here. So first of all, I mean, I probably wouldn't employ this method, to be honest with you.
That's what I said.
Did you use this method?
Wait, can't you
No,
just cross
I
it?
I use cross products.
I just guessed.
Yeah, this would probably, I wouldn't use it. Yeah, cross products, so what do you get on this side?
I just
-39.
negative 39, and on this side,
Negative 35.
right, negative 39 is less than negative 35. Take out the 30s, I'll just do the ones column. 9, negative 5, negative 9 is less than negative 5. Right? For what? Shouldn't need a calculator. You get them in chapter 2. That's when the calculators.
Calculator.
Yeah, you have to gut out this one chapter here without the calculator. It is a little brutal at times, but
Gotta stay strong.
again, as you remember last year, you didn't get them till chapter 5. And in 6th grade, you don't ever get them. So you'll be using them. You'll be using them in about 3 weeks here, and then you'll have it the rest of the year. So yeah, and again, you could write equivalent fractions. That's fair game. But cross products, I like what you guys were saying. That's by far the fastest and most effective method just to get this done. So, but I just wanted to illustrate this, that I'm not actually solving this here because all the information I need has been provided to me at this point, and I am done. Again, it's minus 65, 5, 0, and again, it would go on. It's an irrational number. It's never going to end, so, and there's no pattern to it. Okay, 17. Abby,
Equal.
equal?
That's what
Why equal?
I do cross products.
Cross products, do you guys agree?
Yeah.
I agree too. Well, actually, I'm not officially in the book here, but you are correct. Those are equal. Yep. Okay. Ordering. So, pardon? We are. True. So, comparing is the term we use when we have two values. One over here, just looking at two numbers. Ordering is the term we use when there's 3 or more values, because we're not going to try and set up a bunch of less than, greater than, equal than symbols all over the place here. So, more or less the same deal, except the only real difference is one of our tools is kind of taken out of our belt here, and that would be the cross products. Because it's hard to do cross products with all these different fractions. You can't make a comparison evenly between them. So cross products is not going to be an effective solution. So really we're down to 2 choices for these. Fortunately, at least as the book presents them here, they're all in the same format, but same deal. You would want to make a choice. Do I want to deal with fractions or decimals? You would want to get them all in the same format to make any type of comparison. So on the back, do they mix it up? Yeah, on the back here's where they start shuffling you around a little bit. Notice how there's some decimals, there's some fractions. You have to decide. Do I want to make them all decimals or do I want to make them all fractions? There's no right or wrong answer there. But you have to deploy one of those methods. So on the front side though, 2 methods again. When they're decimals, I mean, they're ready to go. Oh dear, that is very foggy looking. All right, when they're decimals, we are all ready to go. So let's look at number 25. And just very briefly. And I'm going to rewrite in a vertical form here. This is 25 right here. Okay. And it says least to greatest. Okay. So if we're going decimals, I mean, if there's 3 and if you could see it in your head, hey, all the power to you. But 26, a little bit farther out there, one you have to do. The challenge is to make sure that you're comparing the right place values to each other. In something like 26, it may be hard. The first one is 45 10,000ths, but the other 2, 42 thousandths, 5 thousandths. So they don't have the same number of place values. So you need to just be careful there. So this is why I'm writing that this way. Because what I can do now is I can just fill in any missing spots with zeros. And when we are comparing values, we always start on the left and move our way down each value until we find a difference. So start on the left. You don't have to write this down, but if you want it, start on the left, work to the right, until a difference in place values occur. Good enough. So for 25, if I start in the greatest place value here, which place value would I start at?
Greatest.
What's the, on the left, what place value would that place be in where I'm starting? The ones column. This is the ones column. So I look at the ones column. Is there anything to learn here? No, they're all the same. So now I go to the tenths column. Anything to learn here? Here, you bet. So at this point here, in truth, none of these numbers really have any value for what we're doing this time because all my answer is determined in the tenths column. Which one's the smallest value? You can just 1, 2, or 3. Yeah, the second one, because 0 tenths is smaller than 5 tenths, which is also smaller than 8 tenths. So there's the first one. Then the last one, and then finally this is the greatest value. And that's correct. And our determination was made in the tenths column. That's where we found that out. So I think personally, again, it can be easiest just to list them in this vertical form. As long as you're lining up the place values properly, you just start, work your way to the left. I don't care if you rewrite them. You can just take your numbers or on quizzes and just write 1, 2, 3 next to them. I'm fine with that. Or if you want to rewrite them, whatever you want. 23. I'm going to let you guys try this one more or less. Here's our 3 values. And we said cross products isn't going to get us anywhere. And you can certainly convert them to decimals, but these are all going to be very, very strange numbers if you convert them to decimals. It would be a ton of work.
Yeah.
Plus, you don't know how many decimal spots you're even going to need. 1, 2, 3 spots, you don't know. I mean, in this one here, when I worked it out, I only needed 1, but you have 3 of them. You have no idea what they are as decimals. You don't know how far you're going to have to work your division problems. So converting them to decimals would be a poor strategy, I think. So what would we want to do? What's the move?
Change the
Right. Find what's the common denominator? You could write it with 30. Actually, I think you're right. I thought it was 18. My bad. Kylie, you want to teach? I'll give you I can sit there. You can school me.
I would have said
Can I
yes.
Well, I thought it was 18, but Kylie put me in my place. So one of the rest of you shut me down, then I'll pass the pencil to you. All right, so what goes up here?
5, negative. Oh, wait.
20.
I don't
Negative
know how many
20.
times.
Here,
Negative 21.
here.
Negative 22.
Which one's my smallest value?
They're in order already.
Yeah. Mr. Walter.
No, it's backwards. Oh.
It is backwards.
They're backwards.
Remember, we talked about the negative values. Negative 22 is smaller than negative 21, which is smaller than negative 20. This one's the smallest. This one's in the middle. This one is the largest. Smallest.
They're in order.
They're in backwards order.
No, this is the smallest over here. Negative 22 is smaller than negative 21. Negative 21 is smaller than negative 20. Okay. All right, last one. I got like 2 more minutes. So try number 31 on your own. 31. This time 31 mixes it up. Greatest. Largest value first. Delete. So at least they're kind enough. They do mix it up, but at least they're kind enough that 2 of them are negative and 2 of them are positive. So we should know which 2 are the greatest, maybe not the order, and we should know which 2 are the smallest, right? We got that part figured out. So, what?
Can you put it up on the screen? I don't have a book. Or just write it down. Does it go 0.5?
So you can save yourself, there's a number of shortcuts here. There are a number of shortcuts you could take. And I say that because, what did I just say before? What are the values that we're actually comparing? We're not necessarily comparing all four of them to each other. Right, we are comparing, we already know that this and this are my greatest values, right? So all I really need to do is compare these two against each other. I don't really care. I don't need to compare these two to these two because I know for a fact that negative values are always smaller than positive values. So, yes,
4, 5, that one's the biggest.
why?
Because that one in the decimal form is 0.4 repeating.
You got it, Abby. Nice job. Yep, we talked about the ninths there, 0.1 repeating, 0.2, and she remembered. So I don't necessarily care about the 4 repeating, but what I really do care about is this hundredth spot right there. That's what I care about the most because that's where my determination is made. That this guy right here is my greatest value, followed by that one second. So same deal here for these. So now, which of these two values is greater? Between these two. Which is the greater, huh?
22?
Yeah.
Maybe.
Negative.
No, actually, the 1152.
Why?
Uh,
So,
like,
in this case here, I mean, I'd probably convert this to a decimal. And I don't need to know the whole thing. I would convert this to a decimal. I don't need to know the whole answer. How far would I need to go?
2.
Probably 2 spots, possibly 3. Because if I got 0.22, I know this is a 0. And again, I could add as many zeros as I need until I reach my different point. And the reason I do that is trying to turn, I know this would be 22 over 100. Well, actually, what am I doing here? And it does turn into 11 over 50. Right. So, right from there, just comparing the denominators, which one's the greater value? Negative 11 over 52 or negative 11 over 50?
Well, yeah, the 50.
Remember, it's backwards now, so...
The 50. Wait, yeah, I think that's what I said.
Got it.
Right, so you could do that, but I'd probably just start turning this one into, you guys can start packing it up here, but this is a 2 minus 104, 6, and this is a 1, so now I got negative. Does this make sense here? Should it be the other way around? Okay, yeah, and there it is, so 21, negative 21 is larger than 20. See you in half an hour, have fun at gym.